Okay, this is the continuation of the substitution and elimination discussion. So we're gonna be seeing a lot of real life examples here. Mm, the sum of two numbers is 67, and their difference is 3. Yeah. So find the two numbers. So we can use substitution and elimination here. But firstly, we need to form the equation first. In order to use substitution and elimination method to solve this kind of problems, we have to form the linear equations first. So let's look at the first sentence. The sum of two numbers is 67. We don't know any of these numbers, right? So we can uh, symbolize them as x and y. So sum of two numbers, sum of x and y is 67. So we have x plus y equals 67 here for the first equation, and their difference, that means you minus them. Y minus x equals 3. Now it doesn't matter if you write minus y. I don't know why they even write y minus x here. It's okay even if you write x minus y, because we just don't know which number is bigger than the other one. So yeah, but for now let's follow the solution given here. So y minus x equals 3. Now we can eliminate or substitute. Yeah. So what they did here, they don't really show you the working. Yeah. So that means we can do it on our own. So some of us prefer elimination method, some of us prefer substitution method, or some of us prefer the substitution and the elimination and substitution combined. So, but in the end, you'll get y equals 35, they say. And okay, the second one, they use the substitution. So substitute y equals 35 into the first equation, and you'll get x equals 32. Right. Now, what happened if you write, instead of y minus x, you write x minus y here? Well, there's a bit difference in result. You will get x equals 35 instead, and you'll get y equals 32 instead. Yeah. And then that's not really a problem. So in the end, the conclusion is the two numbers are 32 and 35, regardless of the which one is x, which one is y. All right. So another problem here. 1 is added to the numerator and 2 to the denominator of a fraction. So we don't know the numerator and denominator initially, right? The value. So we call them x and y. So x over y. I'm going to zoom in here. So it was initially x over y. And then they say we add 1 to the numerator. So here we are, numerator, and 2 to the denominator. So y plus 2. And they say the value obtained is 2 over 3. So it will be equal to 2 over 3. That's how we write them. Now, the second one. What if 2 is subtracted from its numerator? So now the x minus 2. And 1 is subtracted also from the denominator. So y minus 1. And the result will be 1 over 3. Now, okay, we can use elimination, substitution, up to you. And we've covered this on how to solve this kind of equation on the previous topic. So it was cross multiplication, yeah. So 3 you times 2 x plus 1 and the y plus 2 times 2 2, and then you just make sure that in the end the variable x and y are on the left side and the constant is on the right side. And then there you go, you just solve it, and yeah, the answer is given already. You can try it yourself, see if you can get the same answer. Now the sum of the ages of Junwei and his mother is 60. Yeah, we don't know Junwei's age, so we can call it X, and for his mother's age, we can call it Y. So X plus Y is 60. And that forms the first equation. Mhm. Okay, Junwei's mother was 3 times as old as Junwei. So Y is 3. Yeah, let me translate it to a mathematical equation. So Y is 3 times X, right? So where is it? Y is 3 times X. They don't have it here. So what is this actually? Let me see. Is the second equation? Oh, sorry. Yeah, I overlooked this one. So 2 years ago. So Junwei's mother, yeah, 2 years ago, her age is Y minus 2, right? So Y minus 2. This one. 3 times, yeah. Okay. So apparently here, different from my perspective, they treat the Junwei's mother as the X. Yeah. So again, let us redo this. So his mother is X, Junwei is Y. So X plus Y is 60. That one. And now the mother's age, yeah, 2 years ago, which is X plus 2, is 3 times Junwei, also 2 years ago. That means Y minus 2. So again, yeah, X minus 2, 3 times Y minus 2. Yeah. So that is what we have here. And then, yep, what they do here is they do simplification first. So they simplify this equation first because it's kind of messy, right? So we can times in the 3 first, become 3y minus 6 here. And then we can move the y to the left side. No, they don't actually do that. They just leave it as x equals 3y minus 4. Maybe because they want to do substitution. Yes, they did. So up to you. If you were trying to do elimination, you better move the 3y to the left side, become x minus 3y equals minus negative 4. And then after you're done with the substitution elimination, you'll get the y or x, both, yeah. In the end, Junwei's present age, 16, and his mother's is 28. Yeah. The sum of the digits of a two-digit number is 8. Okay, two-digit number. So we don't know both the digits, so x and y. So x plus y equals 8 here below. When the digits of the number are reversed and the number is subtracted from the original number, the result obtained is 18. Now, here's a bit tricky. So when the number are reversed, yeah, and the number is subtracted from the original number. Okay. Now, think of number, two-digit number. You can think of one, but I think of 18. Yeah, right now suddenly came through my mind 18. So let's take an example of a two-digit number 18. So imagine 8. We want to say 18 as x and y. So it will be not x plus y. Instead, it will be 10x plus y. Why is that? Let's see. 18, yeah, is composed by two digits, which is 1 and 8. Now, if I write 18 as just x plus y, that will be 1 plus 8, right? There will be 9, which kind of different with our what we want. So we want 18, right? But when we separate digits, become 1 and 8, and we plus them, it will not become 18. It will become 9. So how can we um, turn it into x and y form, but still, yeah, remain the original value, which is 18? So we can times 10 to the first digit, which is the 10th, right? So 18 separate into 1 and 8. The 1, which is the x, times 10 needs to be multiplied by 10, yeah, so become 10 and plus 8. Now 10x plus y, if the x is 1 and y is 8, it will become 18. Another example, let's say 98, okay? So if the x is 9 and the y is 10, the x also need to be multiplied by 10. So 9 times 10, 90, plus 10, plus 8, 98, yeah? Yeah. The reason is pretty simple, because the first digit is the 10th, okay? Okay, now minus. Why minus? Because the questions say that the number is subtracted, so minus. Subtracted from what? The original number, but reverse. So yeah, so we just reverse the x and y to become y and x, just like that. And there you go, the second equation, yeah. Oh yeah, now I know why I came up with the number 18, because I just saw it on in the question, and I just unconsciously taking that number into my mind. So yeah, okay. Do not be confused with the 18 that I just talked about before, and with this 18, the 18 before was just an example, okay? So go on. So we need to simplify this equation, right? Oh, it will just become x minus y equals 2. Yeah, in the end, you can divide them all by 9 to make it smaller. So in the end, first equation is x plus y equals 10, and second equation is x minus y equals 2. And then there you go, you solve it. So original number was 53. How do you know? Because you got the x is 5 and y is 3. So the original number will be this, 10x plus y. So 5 times 10, 50, plus y, which is 3, 53. Or the easier way is just you combine them. So first digit is 5, second digit is 3, so 53. Yeah. So especially for digits, yeah, you need to do this thing. You need to multiply the first digit with x, with the 10. Yeah. And that's it. That's the end of these slides, and our discussion is finished for today. So we're gonna see you on the next topic.